Yes, hello. Hello, Fulvani, Akash, Patatri, hello everyone. So first of all, we will be revising something, whatever I taught initially. Then a revision will take maximum 30 minutes or maximum 15 to 20 minutes because I hope you have already seen all these videos. Then we will be solving numericals. Okay, numericals and different kinds of questions that are like those kinds of questions are coming in IIT JAM examination. Fine. Yes, Akash, Fulvani, Patatri, Rupak, Shibras, Kanchan. Everybody, good afternoon to all of you. Yes, yes. So, are you ready? Just before I start this live session, please tell me how many of you have watched the videos? How many of you have watched the video? Yes, Jerin, good evening. Narendra, good evening. Yes, hello. How many of you have watched the video? Like complete video on gaseous state? How many of you? Okay, like first, I am not talking about the first time. I am talking about how many of you have revised. How many of you have revised the chapter? Okay, great. Yes, Shumit. Okay, you have. Okay, great. Fine then. So now, actually, what happened? Yesterday I couldn't complete my numericals, all those things. I was preparing, I was finding, but I have a lot of other jobs, so I couldn't complete it. But yes, now I'll be taking this whole revision and numerical class, and at night, as usual, I'll be taking your chemical kinetics chapter. Fine. At night, I'll be taking chemical kinetics chapter, like as usual, it is going on. Fine. Okay, there is no issue. If you haven't watched it, then you have to watch it first, then you can easily understand the numericals. So in this video, I won't tell you why this is happening, why that is happening. If you have any issue, you can ask me. I will be explaining then, but I will not explain from my side that why it is happening or why that is happening, because it's a like revision class. So I will be telling you, okay, this is happening, and this you have to remember. This kind of question generally comes from this section. Those kinds of thing I will be continuing in this class. Fine. So after this class, if you try to solve your previous year question paper, I will be recommending you to solve the previous year question paper once this class is over, right? So what happens, you can easily understand, okay, now I can solve these questions. Even you will get to know a lot of new things means application based things from this chapter. Although this chapter is very small, but a question generally comes from one or two questions generally comes from this chapter. So you have to be specific, because from this chapter you can't like your question let go. Okay, you have to solve this question, and easily you can get 2 or 3 marks in IIT JAM examination. Fine. So without further time wasting, I am starting, because it's like I have to do the revision first, then I will be move forward to the numerical section. But before I start, I just want to tell you, keep your calculator ready with you. Okay, keep your calculator ready with you. Calculator, I am talking about calculator, because you will be needing your calculator whenever you will be solving your numerical, because first of all, I will be giving you the question paper. Then I will be telling you to solve the question. Once you solve this question, then I will be showing you the answers. I have all the answers as well. Okay, so then I will be showing you the answers, so that you can like have self-confidence. Yes, you can solve those questions. I will be giving you sometimes like 2 minutes, 3 minutes, like that. Fine. So keep your calculator along with you. So I'm starting then. Great. Okay, you don't have calculator. Then use your brain. Fine. Then use your brain. Great. So gaseous state. So what happens in gaseous state? As I already told you, in gaseous state, a lot of molecules generally moves here and there, and they collide to each other. So whenever they are colliding, these kind of velocity distributions are possible. As gaseous molecules are distributed in 3 dimensions, so we will be incorporating, or we will be discussing the Maxwell velocity distribution, that is in 3 dimensions. We don't want to discuss 2-dimensional distribution or 1-dimensional distribution. Actually, these are not in your syllabus. In your syllabus, specifically it is written that Maxwell-Boltzmann distribution law, like that it is written. Fine. So we will be continuing only with this, that is in your syllabus. These two are not in your syllabus. So in case of Maxwell distribution, speed distribution, you get this expression. So I don't want to like derive this expression. I am just telling you to remember this expression by practicing. Fine. So in this expression is important, but the more important is that this plot. Okay, so in this plot, if you look at this plot is a Gaussian plot, like it is looking like this. So remember, it is x-axis, it is y-axis, right? So this plot is starting by touching the x-axis. Remember, this plot is starting by touching the x-axis. It is not starting by touching the y-axis like that. No, it is not. It is starting by touching the x-axis, right? This is your plot. This is called a Gaussian plot. Okay, so Gaussian plot means, let me make you understand this thing. So here it is your area. This is the total area of the plot, and this plot will meet to the x-axis, that is representing velocity at infinite, right? That's why I am doing this parallel. So it will meet at infinite, fine. And this area equals to what? If I consider this area of the plot is equals to what? The number of molecules, the number of gas molecules present over here. You remember that? So in this plot, if you have seen two different parts. What are those parts? First of all, this part and this part. So in this part, what is happening? Your velocity is increasing. Velocity, with the increase of velocity, fraction of molecules are increasing, right? That means at this velocity range, the number of molecules are increasing over here. But if you check, okay, if you are increasing your velocity more, that means if you are considering more velocity, then again the fraction of molecule is decreasing. That means, what can I say from here? That a lot of molecules present at this velocity, a lot of molecules are present at this velocity, a lot of molecules are present at this velocity. So suppose this is your, like, I am dividing this plot into two parts. This is your low velocity range, this is your high velocity range. So low velocity range means, if you look at this expression, so in this expression you have two terms. Which one? One is this term, another is this term. Both of these terms are containing velocity c, okay, velocity c. So at low velocity range, that means if I talk about this range, then at low velocity range, c square term is predominant. I mean, this term is predominant, this term is not predominant. That means this term is controlling the plot. That's why you are getting like increment of the fraction of molecules. Okay, but after this point, if you are going to higher velocity range, so this is called higher velocity range. Okay, higher velocity range. So before this point, it will be your lower velocity range. After this point, it will be your higher velocity range. So if you are going higher velocity range, then you are seeing that now your fraction of molecule is decreasing. So fraction of molecule means this quantity. So this quantity is decreasing. Why? Because now out of this two term, this term is getting predominant, not this one. So at high velocity range, this term is predominant, not this. So that's why I have written this. And at low velocity range, this term is predominant. That's why your plot is looking like this. Okay, perfect. Now the thing is, okay, it's great. We understood the plot. Now, if you look at this plot, a lot of features are there in this plot. So if you consider this point, like maximum height means what? This term represents the number of fraction of number of molecules. Okay, so the number of molecules or the maximum number of molecules are present at this velocity, right? This x-axis represents velocity and this axis represents number of molecules or fraction of total number of molecules. So a particular fraction of total number of molecules are present at this velocity, and this is the maximum velocity where maximum number of molecules or gas molecules are present. If you are considering more higher velocity, less number of molecules are present. That means less height, less number of molecule. More velocity, less number of molecule. More velocity, less number of molecule. So at the maximum velocity where maximum number of molecules are present, that velocity is called most probable velocity Cm. Okay, most probable velocity Cm. So this is my most probable velocity Cm. Remember, this point corresponds to this velocity. This velocity is my most probable velocity. Got it? Now, if I talk about any area, so I told you already that the total area under the curve, this total area is called like what? Total area called like total number of molecules. Total area is called total number of molecules in the system. But if I consider a particular area, so what will happen? So I'll be saying, okay, this area belongs to this velocity range. So I'll be telling you that this area represents the total number of molecules present in this velocity range. Yeah. total number of molecules present in these particular velocity range. So I am considering only these velocity range. So in these velocity range, suppose 10 molecules are present. So this area will represent 10 molecules and total areas represent suppose 100 molecules. So total area is representing 100 molecules. This area is representing only 10 molecules. This is the significance of particular area of the plot that you are getting from Maxwell velocity distribution plot, right? Next, effect of temperature. What happens if you increase your temperature? Simply, if you increase your temperature, your plot height decreases. Look at this. You have T1, you have T2. Okay, so T2 is greater than T1. That means you are increasing your temperature from T1 to T2. So whenever you are increasing your temperature, your height, look at this. This was your initial height, belongs to this. This is your final height, belongs to this. That means your height is decreasing. Height is decreasing, right? And also this plot is likely to be this kind of thing, and the second plot is likely to be this kind of thing. That means I can say whenever I am increasing my temperature, the area of the curve is not changing. Area is not changing means the total number of molecules are not changing. The thing only changing is the height of the curve, and another thing, that is the spreadness of the curve. The curve is becoming more spread. The curve is becoming more spread, right? It is getting spread. So what is happening? Whenever it is getting more spread, so your CM, so it was your initial CM at T1, it is your final CM at T2. CM is not decreasing. Don't think CM is decreasing. CM is increasing because these axis represents velocity increment, right? CM is increasing, but the fraction of molecules present at the particular CM is decreasing. So this fraction at T1 temperature initially, like this fraction. So if you are increasing your temperature, fraction of molecules having maximum velocity decreases, or fraction of molecules having more velocity decreases. Okay, that's great. Then coming to molar mass. So in case of molar mass, opposite thing happens. If you are increasing molar mass, so mass of molecule increases, so they cannot move easily. If they cannot move, what will happen? Then what will happen? So initially you had M1 mass. Okay, M1 mass. So initially you have this M1 mass and you are getting this plot. So once you are increasing your mass M2, so M2 is greater than M1. So if you increase your molar mass of the gas molecule, the plot actually shifts towards the left. Initially the plot was shifting from left to right. Left to right. Let me show you. Let me show you left to right. Okay. And now your plot is shifting from right to left because you know the reason. More mass, so velocity will decrease. Okay. And also as it is moving from right to left, so your height is what? Decreasing, increasing. Height is decreasing means your CM is decreasing. Yes, CM was first this, now CM is this. CM is decreasing, but at this CM maximum velocity molecules, fraction of total number of molecules are more. At this CM fraction of total number of molecules are more. Initially you had less fraction of total number of molecules, less fraction. Now you are having more fraction. Yes, you can remember this one. Great. Moving forward, most probable velocity. Applying this MSD, you can derive most probable velocity equation. So you have two different kinds of equation. First of all, CM, most probable velocity. C represents velocity. Okay, CM means most probable velocity. It is actually 2RT divided by capital M. Remember capital M. And here I am using R. Okay, here I am using R. Fine. And you have to know that is R. You have to know that if you are representing with molar gas constant, that is R, you have to use capital M, that is molar mass. Because we are talking about molar. This is called molar gas constant. This is molar mass. Here student does mistake. Please be careful. Here you will be doing some mistake. Capital R belongs to capital M. Okay, remember this point. Capital R belongs to capital M. So R means what? Molar gas constant. Capital M means molar mass. Both are molar. I mean for 1 mole. Got it? And if you consider K is called Boltzmann constant. So if you consider Boltzmann constant, you will be getting small m, normal mass, not molar mass. Not mass of 1 mole molecule, mass of only 1 molecule. So for 1 molecule you are having this mass. Remember, for 1 molecule, okay? For 1 molecule. And this is true for 1 mole molecule. Perfect. So don't do this mistake. So if you are representing R, you have to take M. if you are representing Boltzmann constant, you have to take small m, mass of one gas molecule. And relation between Boltzmann constant and molar gas constant is this: Boltzmann constant is equals to molar gas constant divided by Avogadro number, or I can say molar gas constant equals to Boltzmann's constant multiplied by Na. Why is that? So K is for only one molecule. Remember, look at this. K is true for only one molecule. Okay, and R is true for 1 mole of molecule. 1 mole means what? Avogadro number. So for one molecule, it is K. For 1 mole molecule, that means Avogadro number molecule, Na molecule. K into Na. And this K into Na is called actually R. So this is the relation between molar gas constant and Boltzmann constant. Don't forget this relation. Great. Similarly, if you calculate average velocity, you get this expression. C average equals to root over of 8 RT capital M or 8 KT small m. And don't think that in examination every time it will be given. In 99.99% cases, you have to use this equation. But whenever you are reading the question, please be careful whether it is mass of one molecule or whether it is molar mass. Please be careful. If nothing is given, that means it is molar mass. You can easily know molar mass. Okay. But if check once whether it is molar mass or normal mass. Clear? If it is normal mass, use use K. Fine. Okay, so can you tell me, how many of you can tell me that what is the relation, what is the value of Boltzmann constant? Please comment down. What is the value of Boltzmann constant? Please comment down. What is the value of Boltzmann constant? Boltzmann constant. Please. What is the value of Boltzmann constant? Because the value of R, I will be telling you in the last of this video, in the last section. But can you tell me what is the value of Boltzmann constant and what is the unit of Boltzmann constant? Can you write down in the comment box? Can you write down in the comment box what is the value and what is the unit of Boltzmann constant? Anybody? I am giving you 30 seconds time. Please think and say. Please think and say. No, value, I am talking about value. Like R has value 8.314 like that. So what is the value of Boltzmann constant in SI unit? I am asking for in SI unit. No. Shibras, no. Okay, 1.38 into 10 to the power minus 23 joule per Kelvin. Awesome, Shumit. Very good, Shumit. Very good job. So K, it is called Boltzmann constant. Remember, K is called Boltzmann constant, and it has value in SI. In SI, 1.38 multiplied by 10 to the power minus 23 joule per Kelvin or joule Kelvin inverse. Remember this value, and not only the value but also the unit. Great, but also the unit. Yes, Artam is saying in calorie. Okay, so calorie unit is not too famous like the SI unit. Okay, so you can convert this unit to S calorie, to arc. You can convert it to anyone. If you know the value in joule, you can convert it into calorie. You can convert it into like arc. Right? It's easy. So this is the exact value of Boltzmann constant in SI unit, joule per Kelvin. Great. Don't forget this. And 1 calorie equals to 4.2 joule. So from this equation you can do this. So let me write this one as this thing as well. So 1 calorie, just one second. Yeah, 1 calorie equals to 4.2 joule. You know this relation as well. So you can, from this joule unit, you can easily go to calorie unit. Yes, and also you know that 1 joule equals to 10 to the power 7 arc. So from this unit you can easily go to arc as well. So you don't need to remember everything. You just remember this one. You can easily convert it to calorie, convert it into arc. Perfect. Yes, Arnab, it will be arc. Perfect. Now let's move forward. It was your average velocity. Great. Similarly, RMS velocity means root 3 RT divided by capital M or 3 KT divided by small m. Okay. So now if I tell you, out of this most probable velocity, average velocity and RMS velocity, which one is greater, which one is lower? So let's do a complete comparison between these three. So CM, most probable, average and CRMS. I am taking the ratio of them. It is this. So RT by M, it is common, right, everywhere. So I am cutting this one and this one. I am getting root 2 this. So if you put your value, you will be getting 1.414, 1.596, 1.732. That means RMS velocity is maximum velocity, average velocity little bit lower velocity, then again molar velocity is little bit lower velocity, most probable velocity is far more lower velocity. That means in the x-axis, if I show you from this plot, in the x-axis your velocity is increasing. So RMS velocity is the maximum velocity. So you already know the height, the maximum height belongs to which velocity? Most probable velocity. So C average is little bit more than most probable velocity. So C average will be coming over here, and C RMS is maximum velocity. So C RMS will come over here. So you are going from lower to higher velocity. That's what I am showing you from here. That's what you need to understand. Right? So this is your plot and this is your normal comparison. So just write the expression, you can easily compare them, right? Now next, move forward. Then another thing, another important equation that you need to remember, that is average translational kinetic energy in 3 dimension. 3 dimension, don't forget 3 dimension. 3 dimension means what? 3 dimension means x-axis, y-axis, z-axis. Fine. So for x-axis you will be getting half kt, for y-axis half kt, for z-axis half kt. So if you add this half kt, half kt, half kt, overall you will be getting 3 by 2 kt, that is total in 3D. Okay, so whenever you are like reading your questions, please do notice that whether it is written 3D, 2D or 1D. If it is written 1D, you have to take 2 half kt. If it is written 3D, 3 half kt. If it is written 1D, only 1 half kt. Only half kt, not 3 by 2 kt. Please be careful over here. So every time IIT JAM generally asks you to solve problems from the basics. So whether do you know the basics or not, that you need to like clear. That you need to, they just check that thing. That's why IIT JAM questions becomes a little bit easier if you know the basics. Otherwise you will be doing silly mistakes. And these are the silly mistakes. You know the expression, but you know it from the depth. That's why I am telling you that x, y, z will vary in this way. Fine. Now again, coming to this distribution from kinetic energy from MSD. So you don't need to remember this expression. But just have little bit idea about this expression. This is comparable expression like the previous one, velocity distribution, right? But remember this plot. Why? The previous one was touching the x-axis in this way. Now look at this. It is touching the y-axis. Yes, y-axis. Both of them are Gaussian like plot. Initially that was purely Gaussian plot. It is not purely Gaussian plot, but yeah, looking like more or less same, but it is not touching x-axis. It is touching y-axis. Why? It is your kinetic energy plot, not velocity plot. Velocity and kinetic energy. This is your kinetic energy plot. Ke, kinetic energy, epsilon plot. This is your kinetic energy plot. Great. Fine. Next, Boltzmann barometric distribution law. That means how, if you increase your height, how pressure will vary. That is the main thing of this barometric distribution law. If your pressure is varying, if you are increasing your, if you are going from sea level to the mountain, how your pressure will vary. That is the measure, that is the like basic fundamental things of Boltzmann barometric distribution law. And the basic formula is this. So P0 is what? Pressure at ground. Nothing to worry, I will be solving numerical as well. Using this theory, using this expression. Just understand and do revise. Okay, so P divided by P0 equals to this. You know what is this? I already told you, so I am not going into deep. Fine. Then other expressions. So these expression can be represented in other way also. So P divided by P0, it is representing as pressure. So P means, suppose you are going at 1 kilometer height. So pressure at 1 kilometer height divided by P0 means pressure at the ground. Or you can say Nen, number of mole. So number of mole of gas at 1 kilometer height, number of mole of gas at ground. Similarly, number of density of gas at 1 kilometer height, density of gas at ground. Then concentration of system gas at 1 kilometer at ground, concentration of gas at 1 kilometer height. So whether you are taking pressure, number of mole, density or concentration, these equation can be applicable, and everything will be mgh divided by RT. So e to the power minus mgh divided by RT. So here, lage hath, I want to say something. Do you know what is that? I want to say something. So if I consider here I have used capital M, remember capital M and capital R. Capital M, capital R. Remember, if I want to represent small m, and what I need to do? I just need to change this thing. E to the power minus small m g h divided by kt. Can you visualize? Yes or no? Write in the comment box. Can you visualize why I am doing this? Can you visualize this one? How? So mgh divided by kt. So small m belongs to small k. So whenever you are changing your m from capital to small, r will become what? K. Awesome. Good. Great. Fine. Next, move forward. Graphical representation. So you have this expression that is called Boltzmann barometric distribution law, right? What this expression does? How if you are changing height, your pressure generally decreases because gravitational force attracts the gas molecules. So at ground pressure is more, at the top of Mount Everest pressure is less. That's why we use oxygen mask whenever we are going to the Mount Everest, right? Mountaineers generally use oxygen mask. That is the reason. So this is the expression, and if I plot this expression like P by P0 versus H, what kind of plot I will be getting? Simply, if you increase your height, because of this negative sign, this term will decrease. And how it will decrease? Exponentially. Exponentially decreasing. Linear decrease means this is linear decrease. But as it is E is present, so exponentially it will decrease if you are increasing your height. So you just need to understand and remember this expression, and you just need to understand how this plot is coming. Don't do rectification. Please don't remember. Understand properly. You can easily get your plot in your examination hall. Clear? So please tell me how many of you understood the basics of this plot, that how I have drawn the plot from this expression. How many of you? Please do comment. How many of you? Please, I can see 26 students are watching. Please tell me how many of you understand from the basics how I am drawing this plot without remembering only. How many of you? How many of you? Okay, good, very good, fine. So now let's move forward. So this is your general expression. So now if I tell you, okay, now plot ln p by p0 versus height. Now plot ln p0 versus p by p0 versus height. So what can I do? Just take ln. So now at this moment, let me tell you one thing that I already know, but also I am telling you. What is the difference between ln and log? Simple difference. Ln has base e, log has base 10. That is the difference between ln and log. And e has value between 2 to 3, in between 2 to 3, like that. So how do you equalize your ln to log, or how do you convert your ln to log? Simple. Ln equals to 2.303 log. That is the method you can convert your ln to log. Perfect. So apply this concept in future as well. Remember this expression. So you can convert your ln to log in this way. Then I am taking ln. So now you know that ln has base e, so it will become it will become 1, and this part will come first in this way. So it is your y equals to minus mx plot. So your slope will be negative. That's what your slope. That's how you are getting. Simple. Again, if you understand the temperature effect on this P divided by P0 versus H plot. So you already know that P by P0 H plot is looking like this, exponential decrease. And if I do this experiment at different temperature, what will happen? So if you increase your temperature, your plot will go in this way. So all the plots will show exponential decrease. But if you are increasing your temperature, lower temperature to higher temperature, the plot will go to this higher values. Okay. So you are increasing your temperature from T1 to T3, and your plot will keep on going towards the upper section. Fine, simple. Reason I told you in the detailed video. So I am not going for the reason. If you have question, ask me. But from my side, I want to go to discuss all the things once again. Then degrees of freedom, very very important thing. Degrees of freedom. Okay, there are 3 degrees of freedom: translational, rotational, vibrational. First of all, tell me how many translational degrees of freedom are there for any kinds of molecule, whether it is monatomic, diatomic, triatomic, linear, non-linear. infinite atomic, how many translational mode of motion is there? How many translational mode of motion or how many translational degrees of freedom are there for any kinds of molecule? So remember this point, for whatever molecule you are considering, whether it is monatomic, diatomic, triatomic, it doesn't matter. Translational mode of motion will be 3. Translational mode of motion will be 3. So monatomic, diatomic, triatomic, it doesn't matter. Great. Now rotational degrees of freedom. So remember, I am giving you the shortcut method. You know already these things. Rotational method means what? Rotational degrees of freedom can be 2 types. 2 types means like you can apply this for 2 kinds of molecules. One is linear molecules, another is non-linear molecules. Non-linear. Okay. Non-linear molecules. One is linear molecule, another is non-linear molecule. So now tell me, for linear molecule, how many rotational degrees of freedom you will be getting? Whatever your molecule is diatomic, triatomic, because monoatomic molecule cannot have rotation. Monoatomic molecule cannot have rotation. Diatomic and triatomic molecule or any kind of infinite number of molecule will have rotation. So if your molecule is linear, whether it is di, tri, tetra, penta, hexaatomic, it doesn't matter. Linear molecule will have a particular number of rotational degrees of freedom. Non-linear molecule will have a particular number of rotational motion. Yes, very good. Linear molecule every time will have 2 rotational degrees of freedom. And what about non-linear? Please do comment. What about non-linear? What about non-linear? What about non-linear? Very good, 3, yes. Okay, now it is done. Translational every time it is 3. It is 3, it is 2 linear, 3 for non-linear. I got it. Now coming to vibrational degrees of freedom. So there are 2 kinds of vibrational degrees of freedom. I mean 2 kinds means for 2 kinds of molecules. One is linear molecule, another is non-linear molecule, right? So linear molecule, how many? Anybody tell me? Anybody tell me for linear molecule how many? I am not considering any atoms. I am not considering any atoms. Definitely remember, these rotational and translational degrees of freedom can be seen for n greater than 1. N means number of molecules, number of atoms present in the molecule should be greater than 1. For monoatomic there is no translational or there is no rotational or vibrational. For monoatomic there is no rotational or vibrational. Okay, very good Arnav. Yes, Arnav, relevant Sonu. Okay, very good. It will have 3n minus 5, simple formula. Remember this formula only. And for non-linear it will be 3n minus 6, simple formula. Just remember these 2 formula. Just remember. Put the value of n over here. Put the value of n. You will be getting your expression. Now you can think, okay, I will be applying this concept for monoatomic molecule. That means n equals to 1. If you put n equals to 1, so 3 into 1, 3 minus 5, negative, it will become negative. So that is not possible. Degrees of freedom cannot be negative. That's why for monoatomic molecule there is no degrees of freedom, there is no rotational degrees of freedom, there is no vibrational degrees of freedom. So how many of you exactly sure about that, share about the topic that rotational degrees of freedom or vibrational degrees of freedom, these are not shown by monoatomic molecules? Okay. How many of you? Because remember, monoatomic molecule can spin. Monoatomic molecule can spin, but this spin and this rotation, these are different things. If you have linear molecules, linear molecule can rotate in this way. Here another atom, here another atom. Suppose I am considering diatomic, so they can rotate in this way, and also they can rotate in this way. So this is about linear molecule, and non-linear molecule can rotate in 3 dimensions: x-axis, y-axis, z-axis. But remember, spinning. Monoatomic molecules can spin. You can think, okay, it can spin. Spinning and rotation, these are different things. It is not possible. Okay, don't consider that. Okay, if monoatomic molecule is showing any kind of spin, that doesn't mean that means it is showing like any kind of rotation. Perfect. Don't make this thing like complicated. Great. Now it is about degrees of freedom. My degrees of freedoms are done. I am not going to show you all these calculations once again. You know this, you understood this. Now I am going directly to the heat capacity. So what is heat capacity? Heat capacity means if you are increasing your temperature or if you are applying heat, a system will increase your temperature. So can you tell me the what is the substance, what is the system that has maximum heat capacity on this planet Earth? What is the example of the system? What is the example of the substance that has maximum heat capacity on this planet? Can you tell me? Anybody? Anybody? What is the maximum? What is that substance which has maximum heat capacity? Okay, relevant Sonu, good job. Water has maximum heat capacity on this planet. Okay, so that's why if you boil your water, it takes too much time. But if you are boiling milk, it doesn't take too much time, because water has maximum heat capacity. Like water can have capacity to store heat. Water has maximum capacity to store heat. So as it has maximum capacity, so it will absorb it. So it will absorb a lot of heat, and that takes time. That's why water boils, like water takes time to boil. But milk, it has less heat capacity, so it will absorb very less amount of heat, and after absorbing heat, it will be easily boiling. Okay, that's the thing. Perfect. So now I can divide this heat capacity that I am representing with C, and C will be your dq divided by dt. Heat change, temperature change if you increase your heat. Okay, temperature and heat, this relation is called heat capacity. Perfect. So this heat capacity can be divided into two sections. One is depending upon mass, another is depending upon mode of heat supplied. So forget about this. One is like specific heat capacity and molar heat capacity. Specific means C, normal heat capacity, divided by W, I mean weight of that substance. Molar heat capacity means heat capacity divided by number of mole, that is called molar heat capacity. Molar means for 1 mole. So N is the number of mole, so for N number of mole it is C. For 1 mole it is C by N, and that is called 1 mole. For 1 mole means that is why it is called molar. Molar word, this word means for 1 mole. Remember, molar means for 1 mole. That is called molar heat capacity. So what is the relation between specific heat capacity and molar heat capacity? What is the relation? Cm equals to C divided by N. Cm, you know, Cm equals to C divided by N. N is number of mole, and you already know number of mole means what? Weight divided by molar mass for that substance. So now I can take this molar mass here to there, and I can write C divided by W, and C divided by W means CS. So I can put in this way. So molar mass, molar heat capacity equals to specific heat capacity multiplied by molar mass. This is the relation between these two heat capacity. That is based upon depending upon mass. So if I now consider how how I am supplying heat to that system, to that subject, to that substance or object, based on that I can have two other kinds of heat capacity. One is called Cp and another is called Cv. Heat capacity at constant volume, heat capacity at constant pressure. So Cp means what? Definitely heat capacity. C means what? dq dt at constant volume. Yes, dq dt at constant P. Now from thermodynamics, that calculation I have done in thermodynamics. I have already shown it in thermodynamics. I have already proved it, how this becomes equals to this and this becomes equals to this. I have shown you the proof in thermodynamics chapter, right? So Cv becomes what? Del Q del T V. Okay, because I am just converting this D to del. Also same is true over here. And this Cv becomes del E del Tv, and this Cp becomes del H del Tv. E is your internal energy and H is your enthalpy. That this term you are getting from thermodynamics, and I have shown you the proof how it is becoming this, how it is becoming this in thermodynamics chapter. Perfect. Next one. Coming to this calculation of CVM. So how can you calculate CV? So generally I won't calculate for CV for any number of system, any number of mole, any number of amount. I will be calculating CV for 1 mole. That is called molar CV. Molar CV. Remember what is called? It is called molar CV. Molar CV. That is represented through CVM. So that is for 1 mole. Remember, for 1 mole. For 1 mole only. Okay. I will be calculating this one. So for 1 mole I will be calculating this molar CV. Great. So CVM that means for CV for 1 mole system, 1 mole any compound, 1 mole of any compound, and here we are considering gas, so 1 mole of gas. Perfect. So CBM total becomes equals to what? CB trans, CB rho, CB veep. Okay, CB trans, rho, veep. So you can ask me, how is this possible? How is this possible? So I am showing you how CB total equals to CB trans, CB rho, CB veep. You can ask me, how is this possible? It is very simple calculation. Very simple. Let me show you this one. So CB total, that means what? I can write CB means what? You know, CB means del E del TV. So del E total by del T V, and del E total means what? Total energy means, remember, total energy means what? Total energy means total kinetic energy, right? Total kinetic energy. So del by del T, E total means what? E translational kinetic energy plus E rotational kinetic energy plus E vibrational kinetic energy. Yes, from here what I get? And constant V. Perfect, great, constant V. Now if you separate this out, what you will be getting? Del E trans del T V plus del E rho del T V del E V del T V. Perfect. So now tell me, del E del T V means what? Del E del T V means CB, and here del E trans del T V means what? I can say CB trans plus CB veep, CB rho plus CB vibrational. Yes, look at this. So this is how I get this one. Perfect. Now we have got this trans, rotational, vibrational. And how can I calculate the value? Simple. CBM means what? From equipartition principle of energy, you know. E translational means what? For any molecule, you know, 3/2 kT. I am talking about kinetic energy because translational mode of motion has 3 degrees of freedom, and 1 degree of freedom has what? 1 degree of freedom has half kT energy. So 2 another half kT, 3 another half kT. So x-axis, y-axis, z-axis. So I will be getting 3 half kT. That will become 3/2 kT. So E trans is equal to 3/2 kT, right? And I have to calculate CB trans. CB trans. I will be calculating CBM trans. I will be calculating CBM trans definitely. But for the time being, I am calculating CB trans to show you how. CB trans means what? Del E trans divided by del T at constant V. So forget about that. It is CB trans means this del E trans by del T, that I have done. Now I have put the value of E trans. E trans means 3/2 kT. If I put the value of E trans, I can easily get 3/2 K. T will vanish because I am differentiating with respect to T. So T will vanish. Perfect. So 3/2 K you are getting. So this is for what? This is for one molecule. Don't do mistake over here. This is for one molecule. I told you K is for one molecule. I have to consider for Avogadro number of molecules. That means for 1 mole. That's why I have told you it is for 1 mole I will be calculating. That is called molar CV. So this is CV for one molecule 3/2 K. So for 1 mole, what I will be doing? I will be multiplying. For 1 molecule it is CV 3/2 K. For one mole number of molecule, that is Avogadro number of molecule, I need to multiply with Avogadro number. So K multiplied by Na. What is this? That is R, that I have already shown you. Let me show you once again. Let me show you this one once again. Let me show you this one once again. Where is that? Yes. K multiplied by Na, that is equals to R. Perfect. So whenever you will be putting this thing, okay, where am I? Where should I go? Yes, just give me 1 second. Yeah. So for 1 mole it will become 3/2 K into Na, and K into Na means R, 3/2 R. So CBM trans, now it is not CV, it is CBM. It was your CV, that was represented by K, and it is your CBM, that is represented by R. Great. So that is how you can calculate molar CV. So every time I will be doing this kind of calculation. For one molecule, then I will be multiplying with Avogadro number, that will become R. So why would I show you again and again and again the same thing? I will be showing you, you will be having 3 by 2r, and this 3 by 2r you will be getting directly from degrees of freedom. If you know degrees of freedom, you can easily calculate this. Perfect. So let's do division. Let's do division. You guys tell me. I have already taught you this thing, so I am not going to show you once again. Monoatomic. For monoatomic, you know, translational degrees of freedom is 3. That's why it is 3 by 2 R. Rotational 0, vibrational 0. That's why CBM rot, CBM VIP 0. For diatomic molecule, you know, diatomic molecule is always linear, right? So you know, whatever your molecule is, it doesn't matter. Your translational value will be 3 by 2 R. 3 by 2 R, R, R. Why it is R, R? Apply the concept. It is diatomic linear. Linear means what? 2 degrees of freedom. 2 degrees of freedom, right? So 2 means one is half kT, another is half kT, half kT, only kT, and kT will become R after doing like differentiation with respect to T. So only R. Yes, you are getting this. But you are considering this vibrational degrees of freedom. Why it is R? Because for linear molecule the formula is what? 3n minus 5. So n is 2. 3 into 2 minus 5. 1 belongs to 1 into half R. I am writing directly. So I should get half R. Why I am writing R over here? I mean, why I am multiplying again with 2? Can anybody tell me why I am multiplying with 2? It should be like 1 degrees of freedom for this, for linear molecule. But why it is not half R? Why it is R? Can anybody tell me? I told you in the actual video. I told you this one in the actual video. Can anybody tell me? Anybody can tell me yes or no? Anybody? Okay, awesome, good. Arnav, relevant, Shanu, okay. Kinetic energy and RE, okay. Maybe you are writing potential energy. Yes, definitely. Kinetic energy plus potential energy. There are 2 kinds of vibrational motion. One is kinetic and other potential. So for one degrees of freedom, degrees of freedom will be 1. Here there is no mistake. But whenever you will be implying this concept to energy, so it will one will become kinetic energy, another will become potential energy. For kinetic energy, you will be getting 1 half kT. From potential energy, you will be getting another half kT. That's why every time whatever degrees of freedom you are getting and whatever value you are getting, 1 means you will be multiplying with half kT or half R directly for 1 mole, and you have to multiply with 2 because each has 2 degrees of freedom. Perfect. So if you have 5 degrees of freedom, 5 multiplied by 2, 10 into half kT. That's the thing. That's why I have done this. So similarly for triatomic linear you can do this, for triatomic non-linear you can do this. I am not going into this. It's just wastage of time. I have told you all these things in great detail. Perfect. Now come here. Here I will be showing you something like that. Some interesting thing. Some of you, I have seen already this point, that some of you are getting confused in these relations. Like for 1 mole, for n mole, some of you are getting confused. Okay, some of you are getting confused. Remember I told you CPM, CVM, this means what? For 1 mole. That is called is a molar CP, molar CV. Yes, molar CP, molar CV. So you know this relation. I have already shown you this relation between CP and CB in thermodynamics. How you are getting this relation? I have shown you the proof in thermodynamics, right? CP CB relation for ideal gas is this, right? Now you don't need to forget about this. That's why I am showing you, I am giving you more clarification. CP minus CV, if it is written in this way, it will be NR. Remember, it will be NR, and this is very simplified version. Okay, this is very simplified version. A lot of things are hidden, simplified. So maybe you are getting confused that whether this CP is for 1 mole or it is for n mole. You may get confused. So do one thing, make this expression in this way: n CPM minus n CVM equals to nr. So actually this Cp belongs to this, Cp belongs to this, okay, Cp belongs to this, Cp belongs to this, generally. That means this generally, if I say you, I already told you, Cp minus Cv equals to nr. If I am representing very simply, so it is for n mole, for n mole, n is the number of mole, okay, n is the number of mole, okay. And now if you are calculating value for 1 mole, so n will become 1 and it will become what? It will become for n mole, like it is for n equals to 1, that means Cp will become, Cp will also be for 1 mole. So for 1 mole you will be calling it molar Cp, Cpm, Cvm, and n equals to 1. That's why here n is not there. This is for 1 mole system, this is for n mole system, and I have to apply this concept or this concept based upon my questions. Perfect. So be careful, either this expression or this expression. Most of the cases they generally ask this expression, but if number of mole is given that is other than 1 mole, then you have to use this expression. This expression is true for n mole, okay, n mole. Perfect. Because if you, in this expression, if you put n equals to 1, then this expression, this part will become this and this. Molar. This will become molar, this will become molar. And once you know the relation between Cp and Cv, so I showed you how to calculate Cp, how to calculate Cv, how to calculate Cvm. So once you calculate Cvm, that is for 1 mole, you can easily calculate Cpm, because Cpm will be equals to Cvm plus R. That is the relation for 1 mole, right? So in this way, you can, if you calculate Cvm, you just add R to calculate Cpm. So in this way, I have calculated this the same thing for different kinds of gas as well. Now, the most important thing is about ratio. So whether you are taking Cpm by Cvm or whether you are taking Cp by Cv, everything becomes same. Why? Because 1 mole get cut, n mole get cut. So the ratio becomes equal. And for monoatomic gas, it is ratio becomes 1.66. Remember these values. If you suppose, please tell me, this point is very, very important. Suppose you forgot the value of gamma, I mean ratio value for monoatomic or diatomic or triatomic or triatomic or non-linear. What you do? So if I ask you guys, if you forget the relation between Cp/Cv or like value of gamma, can you calculate from the scratch? If you forget in your examination, if you forget the value of like this gamma for different molecules, can you calculate this from the scratch? Yes or no? Yes or no? Can you calculate? Please tell me, can you calculate this? Yes, that's the thing that I want from you, that you should, if you forget anything, as you understood the basics, you can calculate from anywhere. You don't need to you don't need to do the trophication every case, okay? You don't need to do that. Great. So remember this expression. And for monoatomic, that is the maximum gamma value. Gamma value more than that is impossible, because if you increase the number of atoms in the gas, gamma value decreases. So monoatomic is the minimum atom. Less than monoatomic gas is impossible. So this is the maximum value. Now, another important thing that is about if I tell you, I am comparing Cl2 and N2, okay, Cl2 and N2. So why heat capacity, I mean I am considering Cb suppose, so why heat capacity of Cl2 is more than heat capacity of nitrogen? Why is that? So this is because of molar mass. So you know, these two are diatomic, these two are linear. That means translational fixed, both of them will have same translational mode of motion. Rotational fixed, vibrational will have two different parts, kinetic energy part, potential energy part, right? So now kinetic energy will also be same, but as potential energy of this Cl2 and N2 will be different. Why? Because potential energy depends upon molar mass. It is proportional to molar mass. So more molar mass, more potential energy, more Cv. That's why Cl2 has more molar mass than N2. So that's why Cl2 shows more heat capacity than N2. Correct? Got it? Then this point, at low temperature and at high temperature. So you have to be very careful whenever you are solving this kinds of question. At low temperature, generally molecule doesn't vibrate. At low temperature, molecule doesn't vibrate. Okay, so do you want to see what is the vibration? Do you want to see what is vibration? Let me show you. Just 1 second. Look at this. This is actually called vibration. Okay. This is actually called vibration. That means whenever vibration happens, the bond becomes like this. This bond length changes. This is actually vibration. Vibration means like you are vibrating whenever it's too cold. It's not vibration for molecules. For molecules, vibration means this thing. So at low temperature, this bond length changing, wagging, this kind of thing, rocking, this kind of thing just doesn't happen. For at low temperature. So at low temperature, what do? We ignore the vibrational mode of motion or vibrational CV. Only we consider translational and rotational CV because molecule doesn't vibrate at low temperature. But at high temperature, we have to consider translational, rotational, vibrational mode of motion. Perfect. That is the thing. Okay. So remember at low temperature and high temperature, and you be careful in the examination as well. Maybe some questions are coming from here. Don't do mistake over here. Then forget about this collision number. These things are not too much important, so I am ignoring this. Just remember this expression, like mean free path expression. L equals to 1 divided by root 2 pi sigma square n prime. This expression is too much important. This is the expression for mean free path. Although mean free path is not in your syllabus, but also remember this expression only. Okay, and this sigma value, this n prime value, all these will be given. But maybe sometimes this n prime value cannot be given. You have to calculate n prime. N prime means number of molecules per cc. That means density of like system, gas molecules. Number of molecules per cc, that is your n prime. So how to calculate n prime? Let me show you that one. How to calculate n prime? Number of molecules per cc or per unit volume. So suppose I am considering ideal gas. Even in examination, if you face questions will be asked from ideal gas. Okay, so be careful, be like thankful, be safe. So for Pb equals to nRT, you know this. N means what? Number of mole means number of molecules divided by total number of Avogadro number of molecules, right? So if I do one thing, if I calculate n divided by V from here, I will be getting this, and n divided by V means what? Number of molecules present divided by volume. So number of molecules per unit volume, that is called n prime. That n prime goes to Pna divided by Rtn. Remember, this is the density as well. Density of gas molecules. And this one question I think came from this in IIT JAM 2018. Yes. One question came from using this expression. Okay. So remember this expression. Very, very important expression. So if you are thinking, okay, this is very simple thing, maybe this thing cannot come, but yeah, very simple thing generally comes in your examination. Great. Then move forward. Viscosity of gas. How can you calculate this? Simple. So eta equals to 1 by 3 rho CAL. Okay. But this rho means density, Ca means average velocity. You know the formula of average velocity. It means what? Root over of 8 RT by pi m, capital M. And L is mean free path. So first you have to calculate mean free path, then put it over here, you will be getting viscosity. But remember, this viscosity equation is not too accurate. Experimentally, it has been seen that if I put 1 by 2, that becomes more accurate. So whenever you are solving numericals, my recommendation will be use this expression. But also, sometimes suppose you have MCQ question. Here is the trick. and you are solving this numerical using this expression, but there is no option that you are getting by using this expression. Then what you did, you just use this expression and you got one option correct. So which option you will choose, which formula you will choose? Definitely this one then. But remember, this equation is more accurate. So whenever question comes in NAT section where you have to fill in the blanks type questions, then use this equation. So I hope you got this point. I hope you got my point, right? Then ideal and real gas. You know this concept. What is ideal gas? What is real gas? Ideal gas follows this equation: Pv equals to nRT. It follows Boyle's law, it follows Charles' law, it follows combination of Boyle's and Charles' law. You know this. Okay? Perfect. So I am getting one interesting question. How the temperature and pressure influence the viscosity? It's very easy. You just need to apply some basic concepts. Look at this. Here you are having mean free path, right? Here you are having mean free path. And you know how mean free path generally varies with temperature and pressure. How? I showed you. Mean free path generally inversely proportional to pressure. Mean free path is proportional to temperature. So as your eta is proportional to mean free path, therefore I can say eta will be inversely proportional to temperature, inversely proportional to pressure, and eta will be and also eta will be, just 1 second, eta will be viscosity will be proportional to temperature. So if it is happening, you are increasing pressure, viscosity will decrease. Increasing temperature, viscosity will decrease. So whenever you are applying the concept of temperature, maybe some other terms are varying. Okay, so what happens if you are increasing your temperature, viscosity generally does what? Viscosity increases or decreases? Decreases, I think, as per okay, CA term is also dependent upon pressure. Yes, that's why I am telling you. That's whenever you are considering only this, so CA term will vary. Okay, so you have to consider both of these terms. So from here directly you can understand that. But I told you this concept in electrochemistry chapter. Can you remember? Electrochemistry chapter. I told you this concept. Whenever I was talking about D. Y. Hooker-Onsoger theory of electrolytic conduction for strong electrolytes, I told you this concept. What happens actually? If you increase your viscosity, if you increase your temperature, I think your viscosity will decrease. Yeah. So because here two terms are incorporated, that's why that's the thing is happening over here. Now next, move forward. Fine. Real gas. Real gas means what? The gas which are present around you. Those are called real gas. So real gas, deviation from ideal nature. Fine. So now ideal gas is a perfect gas. Ideal gas is also called perfect gas. You know this. Perfect gas. Yeah. So real gas is not perfect. So how would you decide that, okay, you have a lot of real gas. You have carbon dioxide, nitrogen, oxygen, hydrogen, all these are real gas. But you have to have a reference with which you will be comparing your real gas. So ideal gas should be your reference and your real gas will deviate from that reference value. That is called deviation from ideal nature. That will be shown by real gases. Perfect. So deviation deviation can be done through any factor, like first of all compressibility factor. So compressibility factor means molar experimental value, that means molar volume for real gas divided by molar volume for ideal gas. And if I am multiplying with P and P, so it is becoming ppm and ppm for molar volume for 1 mole system. For 1 mole system, for ideal gas, you know, Pv equals to nRT, and as I am considering 1 mole, Pv will become RT, but for real gas, ppm will still be your ppm. You cannot change it, okay, because for real gas, it is not true. Now, there are three possibilities. If Z is greater than equals to 1, that means real gas behaves ideally. Z is not equal to 1, that means two possibilities is coming also. Z is not equal to 1 means real gas will not behave ideally, right? So not equal to 1 means that can be Z can be greater than 1 or Z can be less than 1. So if Z is greater than 1, that means Vm real is greater than Vm ideal, positive deviation will happen. That deviation is called positive deviation from ideal nature. Okay. And if Z less than 1, negative deviation definitely. Okay. So if you look at this plot, I can make you understand about the positive deviation. This is the line for ideal gas. Some of the gas are showing these kind of properties. Some of the gas are showing, first of all, negative deviation, then it is showing positive deviation. So at lower pressure it is showing negative deviation, at higher pressure it is showing positive deviation. A deviation is present. So I can say one more thing from here, that is, if the real gas either will show positive deviation or will show negative deviation. So can you tell me the condition when gas doesn't show any kind of deviation, or I can say your real gas becomes ideal gas? Can you tell me that condition? Can you tell me the condition, at what condition your real gas will behave ideally? Anybody? Write in the comment box. Write down in the comment box. At what condition your real gas behaves ideally? Low pressure, high temperature. Very good. Yes, Kundan. Kundan is smart. Okay. Kundan is very smart. Okay. At Z equals to 1. I was talking about conditions. So remember, I told you already. Final conclusion. Remember the video. Final conclusion. How I showed you. I am not going to discuss those explanation once again. At low pressure and high temperature, real gas will behave ideally. And I showed you how it is happening. From this plot and from this plot, I showed you why real gas behaves ideally at low temperature, low pressure and high temperature. Yes. So remember this point, very important point. One question came from this, using this simple like conclusion. Okay. In IIT JAM 2018 maybe. Next. First of all, I have two kinds of gases. One is ideal gases, another is real gases. So you cannot liquefy your ideal gases, but real gases can be liquefied. So what do you mean by that? That means in ideal gases, remember, no attraction, no interaction I can write, or no attraction is there. But for real gases, attractions are there. So as attractions are there, so gas molecule will attract each other, and whenever you can easily liquefy them. That's why real gas, that means whatever gas is present in nature, you can liquefy them. Liquid nitrogen, liquid hydrogen, because already attractions are there. But real gas, there is no, but for ideal gas, you cannot liquefy this. Why? Because there is no attraction. Is that possible in reality? No, it is not possible. It is not possible in reality. That's why ideal gas is not present in nature. All the gas that those are present in nature are real gas. We use ideal gas concept to understand the deviation of real gas from a perfect value, from a like reference or standard value. That is the use of ideal gas. There is no real existence of real ideal gases in nature. All gases in nature are real. Then move forward. I can show you the deviation from alpha and beta. Alpha is called coefficient of thermal expansion, beta is called compressibility. We talked about this in thermodynamics chapter as well, right? So how can I do that? So what happens for ideal gas? If I consider for ideal gas, alpha equals to 1 by T at constant pressure. That means for ideal gas, alpha depends upon T only at constant pressure. If I consider for ideal gas, beta, for ideal gas, so your beta becomes 1 by P. That means for ideal gas, beta depends upon P only. So for ideal gas, alpha depends upon T only, beta depends upon P only for ideal gas. Okay. But if you consider real gas, alpha depends upon both P and T, beta depends upon both P and T. and that I have shown you in my thermodynamics CP/CV relation, or you can show this from there. You can easily show this from there, from the expression that I have already derived. You can do some other mathematics over there and you can prove this, that for alpha and beta, in the alpha beta expression, both T and P terms are present. These terms are present means what? Alpha is depending upon T and P, beta will be depending upon T and P. Simple. Okay. Next, move forward. Deviation through Andrews curve. Andrews curve means critical temperature, critical volume, critical pressure. So this point is called critical point. The temperature belongs to this point is called critical temperature, pressure belongs to this point, critical pressure, volume belongs to this point is called critical volume. So what is the significance of this point? So it is the maximum temperature where you can liquefy your gas. After this temperature you cannot liquefy your gas. That means what? That is the maximum temperature at which your gas remains a real gas. After that temperature your gas will become ideal gas. Yes, so ideal gas cannot be liquefied. So this temperature is the maximum temperature where you can liquefy your gas. Okay, so now remember this temperature is called critical temperature, and critical temperature will have a particular volume that is called critical volume, and at that temperature gas will have a particular pressure that is called critical pressure. Below this pressure you can liquefy your gas. So if you look at this plot, you are getting this section, and in this section what happens? Before these sections, that is low volume section. Low volume means liquid, high volume means gas. In between to this section is actually mixture of liquid and gas. You cannot differentiate your liquid and gas over here. They are liquid and gas, they are in equilibrium state. You cannot differentiate your liquid. Suppose you are taking, you are like, this is your like this is one beaker, this is one test tube. Suppose theoretically you are putting your beaker over here and you are taking you want to take only liquid, you don't want gas. So if you are putting a beaker over here and you are taking out some system mixtures, so both liquid and gas both will come. You cannot separate these two out in this section. Perfect. And this is the maximum point. Till that temperature or till that pressure or till that volume you can do this. You cannot like separate. After that everything will be gas. So now remember, I told you at higher temperature and lower pressure real gas behaves ideally. This is your real gas that can be liquefied. But you are increasing temperature, that means at higher temperature this gas is becoming ideal. Yes, it is also like maintaining this same formula or following the same plot. This plot is called Andrews plot. So the temperature, pressure and volume will be critical. That's why I need to know about critical temperature, critical volume, critical pressure, and these are the equations that you need to know, that you need to remember. These are very important expressions. You need to remember all these three expressions. I didn't show you the derivation of these expressions. I didn't show you because those are not needed. Derivation will like give you a lot of headache. If you want derivation, you can WhatsApp me. In the WhatsApp group, in your group, you can ask me. I will be sending you the derivation, but those are not needed at this moment. I can show you the derivation, but that will create headache on you. Then, what is critical coefficient? Critical coefficient is a term that tells you RTC divided by PCVC equals to 8 by 3. So this is called critical coefficient. This term is called critical coefficient. Critical coefficient has value 8 divided by 3. So how I calculated that? I just put value of TC, PC and BC from these expressions and I got 8 by 3. This is called critical coefficient that I am getting from critical temperature, pressure and volume. Okay, fine. Real gas equation. Real gas equation means ideal gas equation is PV equals to nRT. In case of real gas, with the pressure you are adding this term, and with the volume you are minusing this term, and finally you are getting this part. Okay, and here during this derivation from PV equals to nRT to P, this expression, like this expression is true for real gas. That means the gas that is present in nature. So for real gas this expression is true, and this expression is done calculated by Van der Waals, scientist Van der Waals. So it is also called Van der Waals equation or real gas equation, and all the gas present in nature are following this Van der Waals expression. Okay, so I am not going to show you this Van der Waals expression how I am getting it, but remember here excluded volume formula is very important. Okay, excluded volume, that is equals to volume of one molecule multiplied by 8, and this formula is for per pair of molecule. Per pair of molecule, this formula is correct. If you are considering for one molecule, your excluded volume will become this. Yes, 4 you have to divide it by 2 because for one molecule. Then move forward. Correction pressure is done, everything is done. I am not showing you how we are getting this. Remember the unit of A and B. Remember the unit of A and B. Here one thing is very important that I just want to incorporate, and I just want to tell you. Suppose I am telling you what A term represents. What A term represents. If value of this van der Waals constant A is more, what will be the conclusion? So value of A is actually proportional to A's of liquefaction. Remember this point. So if value of A is more, value of van der Waals constant is more, that suppose I have two gases, gas 1, gas 2. For gas A, for real gas A, value is 10. Value of A equals to 10. For real gas B, value of A equals to 8. So as value of A is more, so I can liquefy my number 1 gas very easily. So more A value means A's of liquefaction. That means you can easily liquefy that gas. Remember, this point is very important. MCQ question comes from here as well. If your value is more, you can easily liquefy your gas. If your value is less, you cannot easily liquefy your gas. Okay. So suppose 3-4 gases are there, and their A values and B values are there. Just look at the A values. Value of A is more A's of liquefaction. Value of A is less, it will be tough to liquefy that gas. That means if A is increasing, real nature increasing. A is decreasing, real nature decreasing. So A proportional to real nature. You can remember A proportional to real nature of gas. Real nature of gas. Or I can write also A proportional to A inversely proportional to ideal nature. A inversely proportional to ideal nature. That means if A is increasing, you can easily liquefy the gas. You can easily liquefy the gas means what? Ideal gas cannot be liquefied. So ideal nature is decreasing. Yeah, got it? Got this point? Please write in the comment box. Got this point? Got this point? Got this point? Please do comment in the comment box. Ideal nature, real nature, liquefaction based upon the value of A. Based upon the value of A. Okay, perfect. I will be applying this concept in numerical as well. This is called reduced equation of state. It is not too much important, but yes, reduced pressure is represented through normal pressure divided by critical pressure. Normal volume divided by critical volume. Normal temperature divided by critical temperature. And if you put P, V and T value, like P, V and T value from these expressions, you will be getting an expression that is called reduced equation of state. Okay, reduced equation of state. I told you this is not too much important, but yeah, you can just remember this. Fine. Then forget about this. Yes, another formula that is very important. Okay, so yes, remember this significance. If you look at this Kemaerling equation of state, you will be getting this equation of state. Okay, that is actually for a particular gas, and in the more general form, I can represent this equation of state in this way. And in this expression, if you look at this A, this 1, B, C, D, 1 is called first virial coefficient, B is called second virial coefficient, C is called third virial coefficient. So only first one and second one are too much important. Remember, in examination maybe they are not giving B, they are giving any other term. But you have to understand this is actually second virial coefficient. You have to have business with only this term, second virial coefficient or first virial coefficient. So first virial coefficient does what? So if value of first virial coefficient is 1, gas behaves ideally. So from this equation step, Kemaerling equation state, you can easily get that if first virial coefficient is 1, what do you mean by that? It means gas behaves ideally. So if only this one is present, all these are vanishing. So Pp will become inertic for 1 mole of gas. That means gas is becoming ideal. Perfect. Similarly, significance of the second virial coefficient. So from the second virial coefficient, you actually can calculate the boil temperature. This expression, very important expression. Okay. So at boil temperature, what happens? The temperature at which real gas behaves ideally, that is called boil temperature. Okay. Yeah. Perfect. Boil temperature. Perfect. Great. Then how to calculate density of gas? Actually, we have done this already. PM divided by RT for ideal gas. PM divided by RT. You have calculated this, right? PM divided by RT. Yeah. Remember the density N prime. N prime equals to density. Okay. Just 1 second. Okay. Just 1 second. Just 1 second. PM will not be your density, like you can compare it with density, but yeah, density will be your mass by volume, right? Mass by volume. So in this case I will be considering mass divided by volume. So W divided by V, that is your density. That is another kind of density. So you can represent your density by like number of molecules per volume. That is also called density, but actually if I consider density of gas molecules, then you have to use this expression. How? PV equals to nRT, P equals to nRT by V. So you already know N equals to W by M, weight by molar mass, weight by molecular weight, W by M. So W by V, mass by volume, that will be density. Yeah, don't do mistake. Okay, that is also called density sometimes, but not accurate one. This is more accurate one. You can consider that is number of molecules per cc, that is okay, but here this term is more important. This density is more important density. Great. W by V, PM by RT. Clear or not? Now final thing is about universal gas constant. PV equals to nRT. So this R is called universal gas constant. So CGS it has value this, SI it has value this, calorie unit SI you have value this, liter atmosphere mole inverse Kelvin inverse you have value this. So now my question is when do you use which value? So mole inverse Kelvin inverse, these are common every time. So you have to use this value or this value. How you understand that? That you will be understanding very easily. Look at this. Suppose your pressure is in atm, volume is in liter. That means atm liter. So now fine, liter atm. You will be putting the value of R, this one. Okay. And in gaseous state, if you are using this expression, 99% cases you will be using the last one, because you have pressure, you have volume. So pressure and volume, liter and atmosphere. So in gaseous state, this expression is very important. But in the other field of physical chemistry, you will be applying this concept. Perfect. Got it? You will be applying this concept. Okay. Now we are done. Finally, we are done with the revision classes. More or less we are done. Now we are here to solve numericals. But before I solve numericals, I want to tell you something about Graham's law of diffusion. So this is not in your syllabus. Let me tell you, this is not in your syllabus, but as it is IIT JAM, this is present in your class 11 and class 12. Maybe 1% question generally comes from IIT 11-12 level. 1% questions. Out of 60 questions, maybe 1 question can come. So I cannot take risk. Okay. So how many of you understand the diffusion? Understand the phenomena diffusion? Can you write one line regarding diffusion in the comment box? Just write. I can see 15 students are watching. I need 15 lines from each of you. If you are getting interested, if you are having interest in this, comment. Otherwise, don't comment, because I know most of you will not comment. But my students definitely will comment. Okay, one small hole. Okay, that is diffusion. Okay, anybody? Gas release. Okay, one small hole, gas release. Anybody else? What is diffusion? Just write a significant line regarding diffusion. Whatever you know. Anybody? Okay. Shivraj is saying movements of gas from higher concentration. Very good, Shivraj. Yes. Patatri, higher concentration, lower concentration movement. Very good. Arnab, diffusion is flow from higher concentration to less concentration. Very good. Yes. Anybody else? I told you most of you won't comment. Kundan, Rate of movement of gas into solid. No, that is not diffusion. Rate of movement of gas, not accurate one. Anybody else? 15 seconds more, then I will be starting. I want to be able to take your comment at that time. Okay, let it go. Come back. So it is very simple. Yes, your the Shibras, Arnab and Patatri, they gave very strong answer. Simple. Have you ever done one thing like agarbatti bolte hai, right? I hope you know this. So what do you say? Suppose this is, you have a beaker and you have water in that beaker. What you are doing? You are adding a drop of ink, INK, black ink or blue ink. You are adding a drop of ink into the water. What happens in that case? Your ink generally is concentrated form. So the whole water will become what? Suppose you are using blue ink. So the whole water will become blue after some time. But first of all, whenever you are adding your ink, only ink will make the water blue, only this section. Then it will be getting spread throughout the system. And finally, the whole water will become like blue. Fine. So initially you had this area, then this area, then this area, then this area, then finally whole area is becoming blue. So this phenomena is called diffusion. So initially your ink was in like more concentration, more concentrated. After adding into water, it will be like ink is spreading, and because of that, its concentration is decreasing. So it is going from higher concentration to lower concentration region. That's diffusion. It is a property by which a gas intermix spontaneously to form homogeneous mixture. Yes, very good explanation. So it is not only true for gas, okay? So we are reading gaseous state, that's fine, but it is not only true for gas, but yeah, it is different thing. It is for everybody. Yes, for solid, for concentrated liquid, it is true as well. Fine. So now how fast your concentrated liquid or concentrated system will spread? Suppose what I am doing. Have you ever used like what is called Odomos, good night? Have you used all out good night, like those things? So first of all, whenever you are like plugging it into the plug, what happens? You are far away, suppose you are sitting on the bed and it is your plug. You are just plugging it and switching it on. After some time, you get the flavor of that all out or anything else. That means that all out or that gas is diffusing slowly. So how much speed it is having to reach to your nose. So if it has more rate of diffusion, more velocity, it will reach within some seconds to your nose. If it has less velocity, then it will take more time to reach to your nose, then you will be getting your smell. Fine. That means that is called rate of diffusion. Velocity. What is the velocity of gas, velocity of the system through which it is coming to your nose? You are getting the smell. If it is more, it has more rate of diffusion, it will come very fast. If it has less rate of diffusion, it will come very slowly. So that is called rate of diffusion. That is called rate of diffusion. Okay, rate of diffusion, and that is represented through R. And this rate of diffusion, it depends upon a lot of factors. That depends upon, let me write, I will be writing 3 factors. Like first of all, density. Second, like molar mass. These 2 factors are too much important. Density and molar mass. Okay. So if suppose your gas is more heavier means more molar mass. So if your gas is more heavier, its speed will be less. You understood from what is that? Maxwell's velocity distribution. More molar mass, less distribution, like because its velocity will be less. So if your molar mass is more, velocity is less, so I can say rate will be inversely proportional to molar mass, right? Another point, suppose your gas is more dense. So if it is more dense, it is more heavier, I can say, or mass is proportional to density, you know this. More mass, more density. Again, that means rate will be inversely proportional to mass density as well. That's why R1 divided by R2. So I can write R proportional to rate proportional to 1 by density or 1 by molar mass. And using this formula, we can understand, we can make this relation like R1 divided by R2. R1 means rate for one gas, R2 means rate for another gas. So R1 will be equals to, okay, I am sorry, I just forgot this thing. I have to put a root over. The actual relation is this. Yeah, root over of this. So R1 will be 1 by D1, R2 1 by D2, and there will be a root over sign. Simple. So this is the relation. This is rate for one gas. This is for another gas. So remember these expressions. This is the final expression. Remember these expressions. Okay. Remember these expressions. Please tell me, understood or not? Please tell me, understood or not? Please tell me. Understood or not? Understood or not? Please tell me. If you understood this, try to solve this numerical. You have 5 minutes. I am giving you 5 minutes to solve this numerical. Or just I am giving you 2 minutes to solve this numerical, and tell me, can you solve this or I should solve this? Can you solve this or I should solve this? Till then I am just looking at another expression of rate of diffusion. I just forgot the expression, so I am checking class 11-12 books. Okay. I think I can represent with time as well, right? Please solve the numerical. Solve the numerical. Okay, perfect. I am giving you 2 minutes time. Okay, solve this numerical. If you can't solve this, then tell me. These kind of question you may face. Very basic question. This is very basic questions from diffusion. I have given you the formula. You just need to use it. Use this. Let's see. I am coming back within 30 seconds. Let's see how many of you give me the answer. 7th Benz. Okay. Satakshi Tandon. Okay. I am sorry. I can't spell your name. 9th row. Anybody else? How you are getting 7? How you are getting 7? 2 by 9. Okay. Anybody else? I am waiting for you. Okay. This is very interesting question. That's why I took this question. Okay. So I am solving this. Fine. What is the correct answer? The correct answer is 9. Can you see this? Can you see this? The correct answer is 9. I am explaining, nothing to worry. I am explaining this question. It's just the answer. Okay, it's just the answer. So start from here. Solution section. Yeah. First, I am giving you 1 minute to understand. Then I am explaining you why it is 9. So Tobai and Shatakshi Tandon. Good job. Well done. It's very simple, guys. Just look at this. Here what is happening? A teacher enters a classroom from front door. Suppose it is your front door. It is front door, okay? And it is the back door, okay? Perfect. Teacher is coming from here. Student is coming from here, okay? And student from the back door. There are 13 equidistant rows, 13 rows, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 rows are there, perfect. The teacher releases laughing gas N2O from the first bench. From here, teacher is releasing N2O. Okay, and from the last bench, student is releasing weeping gas. Okay, C6, H11, OBR. So what will happen here? Here diffusion will happen. Diffusion. So this gas will diffuse from here to from this direction to this direction at a particular rate, at a particular velocity, and this gas will come from here to there at a particular rate, at a particular velocity. So these two gas has different molar mass. You can see different molar mass. So as they have different molar mass, they will have different rate of diffusion. So the question is, at which row this gas and this gas will meet? At which row this will meet? And whenever they will meet, the student sitting on that row will start crying. Will start like smiling. both of the thing will happen simultaneously. That is the question. So first of all, they are calculating a rate for N2O, rate for this. That is the molar mass of this and this. Just put, you got 2, nearly equals to 2. Because you just need to tell me the number of row, right? So it is 2. Now N2O diffuses at a twice rate that this. You know this? N2O diffuses, that means what? R-N2O, rate of diffusion of N2O. So R-N2O, what I am getting? Rn2O equals to 2R C6H11 OBR. So rate of N2O is double than this. So rate double means what? It will cover a distance. It is, if it is covering x distance, it will cover what? 2x distance, like that. At the same time. So what I am doing? Suppose I have 13 rows. Okay. So I am thinking from this is first, second, third, fourth, fifth, sixth, seventh, like that. So I am thinking, I don't know at which row they will meet. I don't know which row they will meet. I am considering the row is at x number of row they will meet. So if N2O is releasing coming at x number of row and meeting, so I can say, so C2 C6 H11 OBR will come to total 13 minus x number of row. So if N2 is, I am considering N2 is coming x number of row. So total number of row 13. So it will come at 13 minus x number of row. So that is actually proportional to velocity, like this two times. So this divided by this, rate of N2O divided by rate of this, rate of N2O this, N2O this equals to 2. So from here, if you solve this problem, you will be getting 9. Nearly equals to 9. So now it's 9. Got it? Very interesting question. Next one. Can you solve this question and tell me the answer? You have 2 minutes. You have 2 minutes to solve this question. You have 2 minutes. (82.51, 58.35, 58.34 meter per second). Okay, let's see. Look at this. 58.35, 58.35. Okay, meter per second. 1840 meter per second. They are asking to calculate root mean square, RMS velocity. RMS velocity. So what mistake you have done? So it's very simple. You just need to use this expression. So I'll be checking now that whether the answer is correct or not here, and I'll be telling you what is the mistake that you have done. Okay, you are getting 58.34. Perfect. So let's see what happens. Okay, great. So first of all, CRMS, you know this formula. Perfect. I know guys, you will be doing mistake in unit. You will be doing mistake in unit. That's why I have taken these kinds of question, so that you do mistake, then you learn how and why I am doing mistake. That's the thing. That's why this is the significance of this live session. Fine. So you will be doing this mistake, this kind of mistake. So do one thing guys. We have unlimited time. So whatever solution you have done, please send me or in our WhatsApp group. Okay. Please send me to the WhatsApp group so that I can check where you are doing mistakes. Then I am telling you that here you will be doing mistake, and so that you never do the same mistake. Please send it to the WhatsApp group right now. Take the picture and send it to the WhatsApp group. Send it to the WhatsApp group, please. The answer is in front of you. You can see the answer. Okay. So don't do this kind of whatever mistakes you are doing right now. Please don't do the same mistake in the IIT JAM examination. Break each part of the unit. Okay. Break. Okay. Shiva, you send me the answer. CRMS equals to this 3 into 8.3. Okay. You did this mistake, right? You did this kind of mistake. So now. And that's why I am telling you, whenever you are solving these kind of problems, don't write only the values, also write the units as well. Don't think. Okay, so R value is in, like, if you are taking, okay, I told you to calculate the value in SI unit. So yeah, take all the value in SI unit. Okay, let me take these values. If I take this, I will be getting what? 3. Right in this way. Solve the question in this way. R means in SI, R means, okay, Arnav, let me check. Okay, Arnav has done the same mistake. Okay, R value is what? In SI, 8.314 joule, mole inverse, Kelvin inverse. Great. Write the unit in this way. If you don't want to solve in this way, ignore it. But how I am solving? Solve the question in this way. Temperature is what? Temperature is given what is the temperature? 273 Kelvin, right? Then molar mass of what? Molar mass of hydrogen molecules, right? Hydrogen molecule has molar mass what? In SI 2. In CGS it is 2 gram per mole, right? In SI this one 0.002 kilogram per mole in SI. Don't take in CGS unit, okay? You are mixing CGS and SI both. Don't do this. 0.002 kilogram per mole. That means mole inverse. Yeah. Now do normal mathematics. Mole inverse got cut. Kelvin inverse got cut. So you are having what? Joule and kg. So you cannot cut these two. Yeah, you cannot cut these two. So how, if you can't cut these two, how can you get CRMS in meter per second? So you have to break this joule as well. So not only the values, but also you have to take care of the units as well. Now I hope you understood this point. So what I am getting from here? I am getting like root over of this, like 3 I am putting the value only, okay? 3 into 8.314 into 273 divided by 0.002 it is, and along with that I am writing these units only, like root over of joule per kg, and it is also in like inside the root over of. Don't take this joule and kg outside the root. No, it is inside the root. So I am putting it also inside the root. Now you know 1 joule means what? You can convert it into kg. 1 joule means what? Joule means what? Joule is the energy of unit of energy, right? Energy. So joule equals to energy. So joule equals to what? Kg meter square second to the power minus 2. Kg. So this part is common, okay? Kg meter square second to the power minus 2 divided by only kg. Perfect, great. So kg is getting cut. Now this part is common, okay? This part is common. I mean this part means this part is common, okay? I am playing with the unit only. Then what I am getting? It is root over of m square second to the power minus 2. Then do a root over of. Then what I am getting? I am getting finally this root over of m square s to the power minus 2. That means these two will not be present if I omit this root. S to the power minus 1. That means same thing, meter per second. Got this idea? Got the idea? This is how you should solve this problem. Okay, otherwise you will be doing a mistakes. This is very simple problem, but in IIT JAM examination, student does mistakes. This kind of mistake you will be doing. So now please tell me in the comment box that would you do the same mistake in your life once again? Yes or no? Would you do the same mistake in your life again? So this video will be there after the gaseous state video. Okay, after the gaseous state video, this video will be present. So please, whenever you are getting confused, do watch the video. All these numericals, everything will be there. Even I will be uploading the whole PDF of these slides, so that you can check anytime whenever you want. That's why I am writing in a neat and clean way everything. Okay, next question. Solve it. Solve this question. Solve the numerical. Okay. Okay, I am getting one answer 652.25. Please guys, don't do too fast. Okay, if you are too fast, then you may do mistakes. Fine. So Tobai, what is the unit? What is the unit? You are ignoring the unit. I told you don't underestimate the power of unit. Okay. Don't underestimate the power of unit. Okay, meter per second. I am waiting for one more answer. Okay. Then I'll be giving you the solution of this question. If you are not solving, you will be getting bored simply. If you are not solving, you will be getting bored. I can't help you then. Okay? So you have to solve this. So I am giving you some hint. Density is there. So you know the formula of density. So you can use that formula. If you want to solve in your way, you can solve this. 681, okay, 650 to 681. So both of these answer cannot be correct. Maybe one is correct, another is wrong, or both of, okay. Third one, 461.1. Okay, all of you are getting different answers. Okay, let me show you. This is actually 461. Tobai, very good. Vivek, very good. Awesome, good job. 483, no, Kundan. 461. Okay, you can ask me how I am getting this expression. It is very simple. You know density. You know, I am asking to calculate RMS, CRMS. CRMS means what? CRMS means root over of 3RT divided by M. This is your CRMS, right? And you already know density equals to what? Density equals to, you know, D equals to PM by RT, right? PM divided by RT. This is the density. So if you calculate like from here, if you calculate this value RT by M, what you will be getting? RT by M, you will be getting what? RT by M, you will be getting this P by D. P by D. So now if you put this value of RT by M here to there, this will become what? 3P by D. That's what you are getting. CRMS equals to 3P by D. Yeah. So now oxygen molecule means 32 gram per mole in CGS. Density is given in SI unit 1.429 kg per meter cube. So it is present in SI unit, it is in CGS unit. So convert this from CGS to SI. How can you convert this? 32 means 0.032 kg per mole. Yes, you have converted this value into SI unit. Now you can put your value. Molar mass you do know, density you know already. So you know, okay, molar mass will not be required for you. You just need density, that you know in SI. You just need pressure. How can you calculate pressure? STP is given. STP means what? STP means 1 atm. Okay, so this is the concept of class 9. Standard temperature and pressure 1 atm. I told you in thermodynamics chapter, standard condition. That is why you are forgetting this. You have to apply your concept. Okay, standard condition. Standard condition means what? 1 atm pressure, I told you. So 1 atm, you don't need to know the value of m for this gas to calculate CRMS, because density is given, and in the term of density already you are incorporating your P. You can think, okay, where my molar mass is going. Actually molar mass you don't need to consider, because already in this term all other things are incorporated, right? That's why. So at STP, that means 1 atm. So you are converting this 1 atm to this. Okay, so guys, do one thing. Tobai Vivek Akash, please send me your answer in the WhatsApp group. In the WhatsApp group, please send me your answer. I just want to check how did you solve this. A lot of methods are there as well, right? So in this way you can solve this. And Tobai is saying, okay, Tobai don't want to make this thing too complicated. What he is doing, he is solving in a different manner. He is solving directly from this expression. He is not considering density, what is given. Okay, then also he is getting the correct answer. Yes. Then also he is getting the correct answer. So please send me whatever answer you are getting. Okay, so I hope you understood this point. So ATM means what? You know, ATM means 1 atm equals to this. You know, I hope you know the unit of Pascal. Pascal. Relation between ATM and Pascal, that you need to know. Relation between ATM and Pascal. Remember this equation, 1 atm equals to 1.013 into 10 to the power 5 PA, Pascal. Okay, remember this expression. This Pascal is the unit of pressure in SI. In SI unit, this Pascal is the unit of pressure in SI. Okay, so okay, I thought Vivek you are in Benjamin Bass student, so I just asked you. Nothing to worry. Nothing to worry. Okay, great. And Pascal means what? This. So remember this equation. Now note down this equation. 1 atm equals to this Pascal, and Pascal means this. So this is the unit of pressure in SI unit. Please note down this relation. Maybe in future it will be useful for you. So note down this relation. Okay, Tobai, you took temperature 273. So Tobai, can you tell me? Okay, you considered STP means standard temperature and pressure 273 Kelvin, that means 0 degree Celsius. That's why you got correct answer. Okay, yeah, because STP is there, so STP means basically 0 degree Celsius. Most of the cases we have considered in STP 0 degree Celsius. That's why you got correct answer. But the right method will be this. So please note down 1 atm equals to this Pascal, and 1 Pascal means this kg meter inverse second to the power -2. So 1 atm equals to this amount means Pascal. Forget about this part. I am not telling you to remember this part. But if you want to convert it into joule, then you can do it. Okay, joule is also SI unit, correct? Okay, not STP. No, STP is at 25 degrees Celsius. Okay, so how you are getting it? Because in STP there is a temperature, at a particular temperature we consider STP. So how you are getting that? Vivek is getting same answer, Toba is getting same answer by taking 273 and 298. Okay. So what is the temperature you took from here? Which temperature you took? Because here temperature is not mentioned. Which temperature? You took 298 Kelvin. Okay, but it is not given. It is not given. How can you do this? How can you solve this numerical? So please don't do this kind of thing. Please don't do. Luckily you got right answer. It doesn't mean that every time you are better. No, please don't do this kind of thing. Please don't do. Temperature is not given. How we can consider this? Fine, please don't do this. Now remember this expression and you can solve this in this way. Simply you have 1 atm pressure in STP, so convert 1 atm pressure to this Pascal, and this is the relation. 1 atm means this Pascal and Pascal means this. Yes, 1 atm equals to, yes, 1.013 10 to the power 5. Yeah, whatever you have written, I have written the same thing. Okay, next problem, this one. So there are two parts. Calculate the average, root mean square, and most probable velocity. So you have to calculate average velocity, most RMS velocity, most probable velocity for oxygen molecules at 298 Kelvin. Okay. So first calculate Cm, CAV, Cm and CRMS. Calculate these velocities. And then at what temperature would the hydrogen have the same values of these speeds? First of all, calculate the first part. Average velocity, root mean square velocity, most probable velocity for oxygen molecules. Do calculation first. I am giving you 1 minute to calculate this three. You have calculator, you can calculate this within 1 minute. Then I am showing you the answer. Okay, 12.4 Kelvin. 12.4 Kelvin, you think? Okay, just tell me what is the what is the average? I am telling you to calculate the first three parts: average, root mean square, and RMS. Most, yes, you have. I think you are right. I forgot the value, but I think you are right. Please calculate. So I am giving time because you need to calculate this, and this time if you do mistake, you told me you don't do mistake, so this time if you do mistake, I will eat you. Okay, so be careful. Okay, average 787. Okay, perfect. Average 787. Anybody else? Yes, Siddhant, that is enough. That is not completed. That is not completed yet. So I am thinking that tonight I will be coming once again. Tonight I will be coming and teaching you the complete rotational spectroscopy. But that is enough. Yes, that is enough for NET, GATE, JAM. Yes, that will be enough. Okay, most probable 393, CRMS 481. Average You are wrong, Tobai. Root mean square is 476. 476 and RMS will be what? RMS will be 392. So all of these whatever you have calculated are wrong. Again you have done same mistake. This is the answer. Why you are doing mistake? Why? It's very easy question. You solved this question already. Anybody? Do I need to explain this? I don't want to explain this. Please try to understand. Same thing, simple thing. So first part you can calculate. I am giving you the solution. Understand properly and tell me where you are doing mistake. Write in the comment box where you are doing mistakes. So your answer is also wrong. I think Vivek, you told the answer is 12.4 Kelvin. No, the actual answer is 18.6 Kelvin. Okay, you forgot to take pi. So okay, you forgot. Then other, what about other values? You did mistake in most probable, in RMS. You did same mistake. And this is the solution for final temperature at which these velocity speeds will be equal, same values of okay. So now listen one thing. You can just understand the first part, come to the second part. What I am doing in the second part? So I have got, for the first part I am getting my average velocity, root mean square velocity and most probable velocity. Yes, perfect. So now my question is, this is at 298 Kelvin. So now my question is, at what temperature would hydrogen have the same values of these speeds? Same values means hydrogen has the same average velocity like oxygen has, same root mean square velocity like oxygen has, same most probable velocity like oxygen has. At what temperature? So we are talking about temperature. So you know this RT by root over of RT by M. Root over of RT by M, this part is common in most probable, in RMS, in average. That's why, and this is differentiated by this part and this part only, right? Root 8 by pi, 3 and 2. You can differentiate these two. So if you don't want to solve in this way, you can solve in this way. So for if you are taking average velocity, so root take in this way, root over of 8 RT divided by pi M. For oxygen, they will be equals to root over of 8 RT divided by pi M for hydrogen. So you have to calculate this temperature T2 and it's supposed T1. So T1 is given, or you know this value you already know, 448. Yes. So you can put 448 equals to root over of. You can put 8 value, R value T2. You can need to calculate. You need for hydrogen M is equals to 2 for in SI. Sorry, in CGS. So convert it into SI. Okay, SI, because it is in meter per second. So 0.002, that will be value of M in SI. So once you put this value, then what will happen? You can easily calculate T2 from here. That's what that's in this way you can do this. So at this temperature, they will have same average velocity. You will be getting another temperature. At that temperature you will be having same average velocity. But the thing is, the temperature will be same every time. Do you know why? The reason behind this part, this 8 by pi and 8 by pi, these two parts are common in both of these cases. So this part and this part is getting cut. 8r by pi, 8r by pi is getting cut. So you are comparing what? T1 that is given divided by m for oxygen, T2 that you need to calculate, you know the m. So only this part varies. So there is no significance of this 8 by pi, 8r by pi, 8r by pi. Same is true for this. There is no significance of this 3r. For this there is no significance of this 2r. So every time you will be getting same temperature. So you can calculate your temperature in this way, or you can calculate your temperature by only taking RT by m, or generally T by m. Forget about R as well, because R will also get cut. Perfect. Got it? So you don't need to take this part, because you are comparing this thing and those parts are getting cut, so there is no value of significance of those parts. So if you are confused, don't get confused. Calculate temperature from these for average velocity. At what temperature both will have same average velocity. At what temperature both will have same average velocity. At what temperature both will have same most probable velocity. You can calculate in a different manner. Calculate it, and finally you will be noticing all the temperature is fixed. Same temperature you will be getting. That's why here they are taking same temperature. Got it? So if you don't like this method, it's okay. Calculate any one of this, you will be getting the temperature same as this. So everybody of you is doing the same mistakes. You mistake in unit, mistake in like putting values. So please avoid this. Otherwise, you can understand this. Every question in the examination will be known to you, but you will be doing this kind of mistake. Please, after completing this live session, whenever you will be revising, please do open this video and open this PDF that I will be uploading in the after the gaseous state, and solve these numericals once again for practice. Next one, solve this one. Okay, so can you tell me which concept you will be applying? Which concept you will be applying to solve this numerical? Let's see. Tell me which concept you will be applying to solve this numerical. Let's see who can answer this question. If you can answer this question will be very easy for you. Very good. Boltzmann parametric distribution law. Shiny, Tovai, good. Solve it then. You solved it then solve it. Then solve it. Okay, Paromika sent me one answer. Okay, great. I think she is not doing mistakes. Yes, Praveen, good evening. Actually, we are solving numericals. We are solving numericals. Okay, Vivek, 34.64. Okay, I am waiting for one more answer. So let's see what happens. I have given you all the values that you need. Just put it and do the calculation. And take care of unit. Okay, take care of unit. Take care of unit. So don't ignore the unit and only you are doing calculation. Toba, you are saying 16.94. Okay. Anybody else? Okay, so let's check the answer. 17.64. The correct Tobai's answer is more or less very close to the correct answer. Okay, so I will be considering that as a correct one, maybe. If he is he is putting all the values in a correct manner, right? So just check whether you are right or wrong. So guys, if you have solved this question and your answer is right, please comment that yes, your answer is right, so that I get to know that yes, you have done the right thing. You took both sides in. 17.64. Very good. 64 gram. 17.64 gram. Only gram. No, Arnab, not gram. Okay. No, every answer. Okay, I am sorry. Every answers are wrong. You are not talking about units. You are putting only the values. So molar mass should have some unit, CGS or SI unit. So all of you are wrong. It's absolutely wrong. All of you, if you convert this value, it will become 176.4 gram per mole. That if you are considering gram, you will be having this value. Why you are doing? Why? Every question. Now I hope you got the idea that you need to practice a lot. It is just a mathematics and you can't do mathematics. Guys, please do mathematics properly. You just need to put values, all values are given, you just need to calculate m. Then also you are doing mistake. That means some problem is in your mathematics. Please do solve it properly. And here one important thing, that joule, you need to put joule. Joule means what? kg meter square second to the power minus 2. This is the value of joule. So in the place of joule, every time put this value. Remember, you have to remember this expression. Arnab, still you are wrong. You are giving me answer 17.64, but the correct answer will be 176.4. Okay, solve by taking ln in both sides. Okay, how you are solving, that doesn't matter. If you are taking ln, you will be having correct one. You will be having correct answer. You will be having the correct answer. Okay. Understood or not? Where? Please tell me, where did you do mistake? Where did you do the mistake? Where did you do the mistake? Where did you do the mistake? Please just notice where did you do your mistakes. If you can't check your mistakes, that means you can't learn. Please check your mistake now, then I will be going to the next question. In formula you did mistake. Okay, here don't forget, here it is a negative charge. There is a negative charge over, negative sign over here. Okay. Can I use the formula m equals to RT by GH? M equals to RT by GH. How you are using this? Okay, then mgh equal to RT. No, mgh equal to RT. PV equals to RT. Okay, you are talking about PV work. PV work equals to gravitational work. So you are, I got your point. You are talking about PV work equals to gravitational work. Yes, this one. But this may, or how do you know that these two becomes equal? Gravitational work means mgh. PV work means W minus P external dV. How do you know that these two are equal? So don't go here and there. Just apply the correct formula. This one, simple. Next question. Look at this. This question is looking like too much complications, but no, this question is not too much complicated. This question is easier. This question is easier. Very easy questions. Same formula you need to apply. You need to apply same formula that you have applied already. Two parts are there. So first complete the first part, then go for second part. Second part and first part. Okay. First part and second part. Go one by one. I need correct answer for this. And if you don't practice, if you don't minimize your mistakes, I can't guarantee you that you can crack the examination. Very easy questions these are. So only thing you need to do, you need to calculate and need to put on your calculator. So calculate slowly. That's why I am telling you, calculation, you do calculation very slowly. Don't do too fast. That's why you are doing mistakes. Write your expressions properly. And do revise a lot of times so that you don't forget your expressions. Okay? You don't forget your expressions. Give me the answer of the first question. A. And if you are doing mistakes, nothing to worry, but comment, because you are doing mistakes and you are still commenting. That means you are like you are better. Okay, it doesn't matter that whatever you are doing mistakes or right, that doesn't matter. The thing that matters is you are learning that what is your mistake. That is the motto of this live session. I am giving you this kind of complicated problems. I could give you very simple problems and you can solve it and be happy. Okay, I can solve numericals. But in examination, whenever you will be facing this kind of problems, then you will be doing mistakes. That will not be better. So I don't want to make you feel better right now. I want to make you feel bad for the time being, so that you feel better in future. Okay. So let me write you the formula. Yeah. Okay. Okay, individual molecule has mass 0.1 kg, okay, but occupy no volume. They are point masses, okay. Okay, you have to calculate height. So P divided by P0 equals to e to the power minus mgh by RT or e to the power minus mgh by KT. Okay. These two equations are perfect. At which the number of particles per unit volume falls to 1/1,000,000th of its ground level. So now guys, here you cannot use P by P0. You have to use number of molecules, right? Like N by N0. M divided by N0, because pressure is not given, only number is given, nothing to worry. So it is 1/1,000,000th. 1/1,000,000th means 10 to the power minus 6. So it is N0. It is what? 10 to the power minus 6 N0 equals to, then okay, then which one you will be using, this one or this one? Just use properly. Okay, just 1 second. Yeah, thank you. It is saying per unit volume falls to 1/1,000,000th of its ground level. So this value is 1/1,000,000th of its ground level. 1 by 10 to the power 6 into this. Yes, I am right. Yeah, do the calculation. Do the calculation. I am right. Okay, actually now only I solved the previous question and I got 0. Okay, Shivras, good. If you got that value, then it is better. But it is too close, but not exactly correct. But yeah, your answer will be accepted in IIT JAM examination. Okay. So you have to just put your answer. Okay, that's fine. Solve this one right now. Okay, I have got one answer. Vivek, 168.8 meter. 15,168.8 meter. Okay, I am waiting for one more answer, then I am showing you the correct one. I think it's 10 to the power 6, not negative. Okay, so what I am telling over here, look at this. My question is at 298K, compute the height at which the number of particles per unit volume falls. 2 means this will be the value 2 to 1 millionth of its ground level. So ground level value is N0. 1 millionth means 1 millionth, not 1 million times. Remember, look at this word. It is not 1 million times. 1/3 means what? 1/4 means what? 1/4 means 1/4. That means what? 1/4. Okay, 1 millionth th. Look at this th. 10 to the power 1 by 10 to the power 6 into n0. 10 to the power minus 6 into n0. 1 millionth. 1/4 means 1/4. 1/3 1/3. 1/2 1/2. 1/10 1/10. It's not 10. Yeah. So yes, this is the answer. This is the answer for this question. Oh, why? You did again mistake, Vivek. That's the thing. That's the point over here. So two things up there. If you are using RT expression like this one, then this is your mass of, look at this, the individual molecule weights. So your small m is given, So if you are using small m, use this equation. If you want to use capital M means molar mass of one mole molecule. So one molecule has this mass, 1 mole, that means Avogadro number of molecule has Avogadro number into this mass. That will be your molar mass, capital M. So if you want to use this expression in the place of m, write small m into Avogadro number. If you want to use this equation, you don't need to do anything. Just put 0.1 kg and put Boltzmann constant 1.38 into 10 to the power minus 23 . Look at this. That's why I told you, don't do mistake. Whatever I taught you, everything is from here. Yes, here they are considering generally the molar one. Okay, here they are considering the capital R. I mean this expression. Look at this, it is your joule, Kelvin, okay, it will be Kelvin inverse, okay, Kelvin inverse, mole inverse, R value. Joule means what? Kilogram meter square second to the power minus 2. Remember, याद कर लो या याद कर लो, इसको याद कर लो. जूल मतलब क्या होता है? दिस होता, ये होता है, ठीक है, याद कर लो, इसको रट्टा मार लो. नेक्स्ट क्वेश्चन. Okay, sorry, I forgot. I think you can easily solve the next question, that calculate the time. It is very interesting question. Okay. Is this Amulendu Ghoshal book? No, it's not. It's not that book. Okay, it's not that book. Yeah, I have taken 1 or 2 questions from that book as well, but this is not that book. So calculate the time taken by a molecule to cover this distance. Calculate the time. So this phenomenon is already happening. You are applying Boltzmann biometric distribution law already. So my question is now, calculate the time taken by a molecule to cover a distance of 10 to the power minus 2 meter. That means the same molecule. I am not talking about any other molecule. The same molecule, okay? The same molecule. So it's very easy. So should I go for the second question? Please tell me, should I go for the second question? I hope you have understood this topic. You have understood this topic, this question. Should I go for the second part? Should I go for the second part? This was part A. Part A. Please tell me, should I go for the second part? Yes or no? Okay, fine. So in the second part, calculate the time taken by a molecule to cover a distance 10 to the power minus 2 meter. Okay, 10 to the power minus 2 meter. Fine. So what you need to do? Look at this. Calculate the time taken by a molecule to cover this distance. So molecule, how much time the molecule will take to cover this distance? To go from the ground, if it is going in this direction, height, so this height will be this, like this. I am talking about this distance. So what will be the time required? It is very simple. So whenever you are considering normal, here it is not like given which velocity the molecule is following. So if it is not given that which velocity the molecule is following, you will be taking what? Average velocity. Because average is taking everywhere, average velocity. That's why first of all I am calculating what is the velocity of the molecule. I am calculating first average velocity, because I don't know which velocity the molecule is following. But in generally you take average one, not RMS, not most probable, average one, right? So average velocity is this. Now this distance the molecule is going at 1 second. Average velocity means this meter per second. So from at 1 second this distance is covered, or I can write this distance is covered at 1 second. 10 to the power minus 2 distance, 10 to the power minus 2 meter, 10 to the power minus 2 meter distance will be covered at what second? Just do math. Done that math, you are getting this second. This belongs to 1 year. Okay, this belongs to 1 year. For that molecule, the molecule which is having this amount of mass. Okay, I hope you got this mass. This is hypothetical gas. Okay, hypothetical gas. Look at this mass. The molecule that has 100 gram mass, one molecule has 100 gram mass. So for that 1 year time will take to go 10 to the power minus 2 meter from the ground to the 10 to the power minus 2 meter height. Okay, simple. So it's a different kind of thing, but yes, this part is important as well. Next question, CPCB question. Let's see. Solve this question. Solve this question. Okay, Krishnendu, I got your question. Maybe or may not be. Maybe or may not be, because yes, that book is good, but a lot of things are there which will be a little bit tough for you. Okay, but yeah, that book is good, so I can't give you right answer, but yes, if you follow clearly, then you can easily crack it. Yes. if you follow properly by understanding each and every point. Okay, so I have a call, so just I am picking up. Okay, so don't mind, please solve this problem. Yes, Pooja, hello. Yes, yes. Hello everyone. Okay, tell me what is the answer? What is the answer for this numerical? Please tell me what is the answer for this numerical. So I have given you the volume. This is the unit is in meter cube. Okay, the unit is in meter cube. So that means the volume is given. This amount of joule is raised. This amount of joule to raise. This energy is required to raise its temperature by 10 degree. Okay, calculate CVM. It's very easy question. You just need to use your formula. Assuming that the vibrational modes are inactive, so ignore vibration. What can be the concluded about the structure of the gas molecule? Structure of the gas molecule. I told you this one. Yes, monoatomic, diatomic, polyatomic. I hope you remember this thing. Any comment can I expect from you? Any comment? So forget about the second one. Just answer the first one. CBM for 1 mole. For 1 mole, calculate. Anybody can calculate for 1 mole? Anybody can calculate it for 1 mole? This energy is required, that is delta E, suppose, and this is delta T. And don't ignore this part. Hurry up, let's see. Okay, hello everyone. Okay, 10.46. No, again you did mistake. Not 10.46, it's 20.92. 20.92. For 1 mole, yes, per mole, yes, it is. Per mole, 20.92, yes. So where you are doing mistakes? Let's find out the mistakes. Actually, it's a thermodynamic questions. Okay. Q equals to NCV delta T. You are increasing your temperature by 10 degree, right? Delta T is 10. Okay, sir, you asked for 1 mole. So yes, this is the value for 1 mole. Yes, look at this. Joule, Kelvin inverse, mole inverse. Mole inverse means 1 mole. This is the correct value for 1 mole. Yes, it is correct value for 1 mole, because look at this, guys. Look at this. Look at this. Look at this. Look at this. It is your CBM. CBM means what? Molar heat capacity at constant volume. That means for 1 mole. So formula is what? QV equals to this. So forget about this expression. You know that you know the value. Okay, you know the value already. That del E. Let me write it. Del E, del V. Sorry, del E, del T, V equals to your CB. Right? This is equals to CB, and I told you this CB is actually your N mole for 1 mole. Let me show you, otherwise you won't believe me. CB is for N mole. Let me check, let me show you. I told you sometimes ago just. Got it? Cp minus Cb equals to Nr. Okay? So this Cp and this Cb, these are true for N mole. So this is simplified version. I told you this is simplified version. Actual equation is this: NCPM minus NCBM equals to Nr. Okay, so this Cp means actually NCP. So come back once again. Let me clear this thing. Let me clear this thing. Yes, it is your daily del TV. Okay, so daily means what? Daily means for this one, this joule. Okay, del T is 10. Del T is 10. Perfect. And this is the volume that is given over here. This is the volume that is given over here. Okay, so it is your 104.6. It is your like delta T is your 10. If I am considering delta instead of del. Okay, and then it is true for N mole, right? It is true for N mole. Now this is the volume that is given. Okay, so do you know this formula that 1 mole be equivalent to 22,400 cc? So here what is given? 11.2 in meter cube. So if you convert this cc to meter, what you will be getting? You will be getting 22.4 into 10 to the power minus 3 meter cube. Cc means what? Centimeter cube. Right? So this is the volume. So you know 1 mole equals to 22,004 this cc or this meter cube. So you know this meter cube means what? Half mole. N equals to 1 by 2. So this is true for half mole. This equation you have to calculate for 1 mole, right? 1 mole. CBM value you have to calculate. If you want to calculate CBM, that means for 1 mole, what you need to do? So for half mole, you will be getting this value. Half mole, you will be getting this value. 1 mole, you will be getting what? This value divided by half. So look at this. This value divided by half for 1 mole. That is your expression. Got it? Got it, got it, got it. So if you don't go with this formula, it's fine. You can go directly from this definition. Delta E, change. Delta T, change of temperature, change. This is true. This is for this volume. This volume means half mole. So for half mole, you will be getting this. For 1 mole, you have to divide it through half. Okay, that's why you got wrong answer. Otherwise, you are right. So don't follow. If you don't want to follow this process, ignore it. Follow this process. Please give me confirmation, guys. Where Kundan, Tobai, where are they? Where are they? Where are they? Please, okay, so just say hi. Who are there? Just say hi. Who are there in the live session? Just say hi once. Who are there? Next question. Okay, so from here you can, what is the conclusion? What is the conclusion that you are getting? Okay, what is the conclusion you are getting? Simple. That if I am considering vibrational modes are inactive, okay, then what can be concluded about the structure of the gas molecule? Structure. Okay. So look at this. You have got Cv value this, and you know Cv belongs to Cv trans, Cv rot, Cv veep. Trans, rotational, vibrational. So vibrational is inactive. There is no vibrational. So now if you calculate, you are getting this value, right? So now translational mode of motion, you know, every time it is 3. 3 means 3 multiplied by 1 by 2r. So if you put 3 by 2r, you will be getting translational value, this value. Okay, translational value, this value. So out of total Cv, translational is this, then it will be your only vibrational. So translational is this, vibrational is this. Sorry, rotational. It will be rotational because vibrational is inactive. Vibrational is not there. Okay, so this Cv belongs to only translational and rotational. Translation is this, vibration, rotational is this. So now do back calculation. Translational is fixed for all molecules. So whether it is monatomic, diatomic, triatomic, it doesn't matter. You will be having 3 by 2r every time. But for linear, rotational becomes r, non-linear, rotational becomes 3 by 2r. So this 8.314 is the value of what? R value. That means this 8.3, that is actually belongs to R value. R value means your rotational motion is actually R. That means rotational motion R for which? For linear molecule. That means the conclusion that you are getting for this molecule is actually that this is your linear molecule. Got it? Yes or no? This is translational value, this is rotational value, and this is 8.3, that belongs to R. R is rotational value for which molecule? Linear molecule. Non-linear, it will be 3 by 2R, that means another is this value. And if you add these two, if you add this and this, you will be getting 20.92. Yes. No. Shibres is saying, as since they given vibrational motion is 0, can we directly say it is linear? No. You can't say that. That means you are saying in case of linear molecule, there is no vibration, right? Right? CO2, remember. CO2 has vibration. How? Triatomic linear. 3n minus 5. N is 3. 3 into 3 minus 5, 4. 4r. You will be getting 4r, yes, vibrational degrees of freedom, vibrational Cv 4r for triatomic linear molecule. So linear molecule has vibration. So what you need to do, just need to do back calculation, that you are getting these rotational motion that belongs to a particular value of r. It can be r, it can be 1 by r, it can be 2 by r. So what I need to do, just divide it with 8.314. It is 8.3, it is 8.3, that means 1, it is your r. So for which molecule rotational motion becomes r? Linear or non-linear? Linear. That's why the molecule is linear. Got it? Got it? Shibras, got it? Yes or no? Got that? Yes or no? Okay, great. Next question. Okay, how many questions we left? 1, then 2, then 3, then 4, then 5, then 6 question maybe. Yes. So guys, what I am doing, let it go. Let it go. I am leaving right now, I think. Okay. I am leaving right now. So what I am doing, I am leaving for the time being, and I will be coming because I have to complete my dinner. Okay, so I will be coming after 1 hour or 1.5 hour and finishing the next left 6th question. Okay, I will be finishing that. Bye bye. And I know you are also tired little bit, so just have get some Okay, is the that was enough for today? No, 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 no. I will be coming again at 8:30. Okay, because only 6 questions are left, so that will take only 45 minutes maximum. Fine. So I am coming back at 8:30 and I am finishing the left one. Okay, it is not enough. And once I finish this, I will be merging these 2 videos into one video and I will be uploading that. And whatever mistakes you have done, learn from your mistakes. I am uploading this thing in my once I complete the live session, I will be uploading it in the benzene batch section. Fine. Chemical kinetics. After that, we will be trying it. Okay. Finish one by one. Okay. Chemical kinetics will be going on. And yeah, let's try. Let's see. Bye bye. Meet you soon.